Incidentally, astronomical occasions of great scale happen billions of kilometers away from Earth, resounding presently across the universe. A comparable event is approaching, causing a red giant, even among researchers, to be shocked. A star, arranged around our outer span system, is communicating unpropitious signs across the universe, caught by the James Webb Space Telescope. Cosmologists have discovered incredibly disruptive discoveries about this epic heavenly body. As Brian Cox, a well-known astrophysicist, gives a grave admonition, a pressing question arises: are we on the edge of seeing a disastrous cosmic explosion that could forever alter the natural night sky? Prior to digging into additional information, be sure to subscribe to our channel if you haven't already. The pressing question awaits. Will this blast influence Earth? And will it be noticeable from our planet? Stay tuned as we investigate the answers to these compelling inquiries in this video. Across the vast expanse of the universe, where the show of heavenly birth, life, and death unfolds with captivating mystery, one particular star recently directed the interest and worry of both cosmologists and the general public. The star, known as Betelgeuse, stands out notably in the form of a red supergiant in the Orion constellation. It flaunts its immense size and age, while its striking ruddy shade and fluctuating brilliance have long simmered observers. Recent events have increased interest in this even more heavenly monster. As we delve into the essence of Betelgeuse, we find ourselves nearing the very edge of a potentially stupendous event in the star's life cycle. But what do these changes in Betelgeuse's behavior mean? Might we observe the beginning of a remarkable, grandiose display of impossible extent? Betelgeuse, flaunting a size roughly 1,000 times greater than our Sun, remains a gigantic giant among stars. Its sheer size pushes human imagination to its limits. Imagine a star so massive that if it were to take the Sun's place, its surface would expand past Mars' orbit, wrapping Mercury, Venus, Earth, and Mars in its heaven-sent grasp. This tremendous size not only emphasizes Betelgeuse's physical monstrosity, but also indicates its position in the heavenly cycle through life. As a red supergiant, Betelgeuse is currently in the sunset phase of its existence, marked by expansion and cooling after a lifetime of fusing hydrogen into helium at its core. Concerns are raised regarding Betelgeuse's age. Despite being relatively young in human terms, it's estimated at around 8.5 to 8.8 million years, it still has a lot of time to go within the context of stellar life expectancies. Its current status as a red supergiant symbolizes the zenith of the evolution of stars over millions of years. Characterized by significant changes from a hot blue star to the great red giant we observe today, the journey of stars like Betelgeuse plays out like a story of constant transformation, driven by the relentless forces of nuclear fusion and gravity. One prominent feature of Betelgeuse's current phase is its striking red hue. This dark red color arises from its cooler surface temperature. In contrast to stars like our Sun, which shine at approximately 5,500 Kelvin, Betelgeuse's surface is cooler, around 3,500 Kelvin. This cooler temperature permits Betelgeuse to produce light in shades of red. However, this color is not merely an aesthetic feature. It provides insights into the star's physical condition and the ongoing activities taking place within its vast gaseous domain. Enhancing the interest in Betelgeuse is its unusual color history. Ancient works from Roman and Chinese sources, nearly 1,000 years ago, indicate Betelgeuse used to look yellow. It was only after the 9th century that researchers described it as red. This historical shift in color is not only a footnote in the records of astronomy, but serves as a signpost in the star's transforming journey. The shifting brightness of Betelgeuse adds another layer of intrigue. It acts as a semi-regular variable star, which means its luminosity undergoes periodic variations. This dance of brightness has captivated astronomers and stargazers for centuries. Typically, Betelgeuse follows a 420-day cycle alongside a longer 5-year cycle, noted by Sir John Herschel as early as 1836 and perhaps even earlier in native oral traditions. But what truly makes Betelgeuse stand out is not just its shifting brightness, but its irregularity. Unlike many other stars with predictable patterns, Betelgeuse occasionally departs from its usual rhythm of dimming and brightening. This irregularity points to complex and less-known processes taking place within its enormous structure. Recent significant discoveries have captivated astronomers and stargazers globally. When Betelgeuse experienced a surprising and dramatic change, now widely called the Great Dimming, everything started in late 2019. At that time, Betelgeuse, the red supergiant shining brightly in the night sky and a notable part of the Orion constellation, started going through a mysterious dimming. The dimming was so striking that it lost luminosity at a daily rate of 0.01 magnitudes on average, reducing to its lowest point by February 2020, commonly observable to the naked eye. Even in the midst of light pollution, Betelgeuse essentially faded, making it hard for casual observers to miss. However, there's a critical challenge in tracking the activities of Betelgeuse: the time conundrum. When we observe a star like Betelgeuse, we are not seeing its current state, but rather its past due to the time it takes for light to reach us. Betelgeuse is about 725 light-years away, meaning the light we see today left the star nearly 7 centuries ago. This delay in time complicates efforts to predict and track abrupt shifts in the star's behavior. As we are, in essence, watching events that occurred long ago, the dimming of Betelgeuse is a stark reminder of the complexities and limitations inherent in cosmic observations and our comprehension when dealing with the enormous dimensions of the universe and the time mystery they involve. The captivating journey of Betelgeuse's astronomical performance was meticulously tracked by Andrea Dupree, the director of the Center for Astrophysics at Harvard and Smithsonian, along with her team using the Hubble Space Telescope. They embarked on a 3-year study to monitor changes in Betelgeuse's exterior surroundings. These observations provided an unprecedented understanding of how a variable star like Betelgeuse behaves with its regular expansions and contractions, leading to fluctuations in brightness. The striking sensitivity of Hubble to ultraviolet light made it possible for researchers to probe the layers above Betelgeuse's surface, which were partially heated by the star's turbulent convection cells. Furthermore, a detailed analysis of the Hubble spectra, obtained at various intervals throughout 2019 and 2020, facilitated the measurement of the movement of material within Betelgeuse's outer environment. The study, in particular, concentrated on 2 magnesium lines in the spectra that provide information about the star's atmospheric conditions. Observations revealed material traveling at speeds of around 200,000 miles per hour from Betelgeuse's surface into its outer environment. This heated and dense material eventually expanded millions of miles from Betelgeuse, forming the precursor to the dust cloud responsible for the star's dimming. Dupree and her team estimated that, during the event's 3 months, roughly twice, the usual amount of material from Betelgeuse's southern hemisphere was shed. This significant mass loss is particularly notable because, like all stars, Betelgeuse continuously sheds mass, but at a much higher rate than our Sun. The magnitude of this mass ejection and the resulting dimming sparked discussions among astronomers about whether this event could signal an impending supernova explosion. The proximity of Betelgeuse, located approximately 725 light-years from Earth, adds to the interest. If such an explosion were to occur, it would be visible from Earth, presenting a fascinating opportunity to closely observe a supernova. But the question persists: what does this dimming event mean for Betelgeuse's future? Does it signal an upcoming supernova, or is it simply a brief period in the star's vast and complex journey? Various hypotheses have been proposed to shed light on this phenomenon. One theory suggests a stage in the supernova process is getting underway because of the widespread belief that Betelgeuse is close to the end of its lifespan. Another widely accepted hypothesis implicates dust, possibly originating from the star itself, blocking our view of Betelgeuse. A third explanation examines changes in the star's photosphere, its apparent surface layer, which could affect its apparent brightness. Comprehensive analysis using diverse observational techniques contributed to unraveling this mystery. Spectroscopic assessments showed a decrease in Betelgeuse's effective temperature, indicating a large dark spot on the star's surface. This theory found support in observations revealing a temperature minimum of 170 Kelvin during the dimming period, highlighting significant surface changes. Ultimately, the key to understanding this extraordinary event lies in continued observation and analysis of Betelgeuse's behavior. The phenomenon came from humanity's careful gaze into space. The Hubble Space Telescope's precise observations revealed that Betelgeuse's dimming was most likely the result of a significant ejection of heated material into space. This material came together to form a cloud of dust, blocking part of the star's surface and reducing the amount of light reaching us from Betelgeuse. The formation of the superheated plasma, which erupted from a large convection cell on the surface of the abscess star and traveled through its scorching air to the lower, cooler layers, was blamed for the dust cloud. After cooling, this plasma formed dust particles, resulting in a cloud that blocked light from roughly a quarter of the star's surface. Hubble's ultraviolet light spectroscopic observations, which began in January 2019, played a crucial role. In reconstructing the timeline leading up to Betelgeuse's dimming, these observations detected signs of thick, heated material passing through the star's atmosphere in the months prior to the dimming incident in December 2019. Other ground-based telescopes also noticed the star's diminishing brightness, particularly in its southern hemisphere. Initially, this material appeared brighter than the star's usual luminosity, eventually culminating in the formation of a shadow as it dispersed outward and cooled. The conclusion was straightforward. It's the outward flow of material and the resulting shadow were responsible for the sudden dimming of the star. The scale of this ejection is truly astonishing, pushing Betelgeuse into the cosmic spotlight. The star expelled an estimated 400 billion times the mass typically released as a conventional coronal mass ejection. This expelled material was thought to be enough to offset our moon several times over, marking a major event not only for Betelgeuse but also for advancing our understanding of stellar mechanics. But what implications do these have? The release of such a massive amount of material for Betelgeuse and the broader theories of supernova challenges traditional wisdom. It suggests that red supergiants like Betelgeuse routinely shed mass before reaching their catastrophic peak existence. But the magnitude of this release hints at a potentially more volatile and unpredictable final stage for these stars. Could Betelgeuse be gearing up for a supernova explosion in its grand finale? Later studies made timing speculations of such an event, implying its possibility sooner than anticipated, possibly within a few years. In addition, the bowshot concept adds another crucial layer to the Betelgeuse puzzle. This massive star speeds through space at about 67,000 miles per hour in comparison to its interstellar medium. It creates a bow shock, similar to the wake formed by the bow of a moving boat. This phenomenon originates from the outer layers interacting with interstellar gases and dust, providing a stunning display of the star's dynamic behavior and how it interacts with the universe's milieu. But what about Betelgeuse's recent behavior? Its surface cooling and diminished density, observed following the ejection, leave the star in a condition that persists even after years. Hydrodynamic simulations suggest a link between the star's convective activities, the subsequent mass ejection, and changes in its oscillation modes. This ongoing instability raises questions concerning the internal processes that drive these changes and their potential implications for the star's future. Additionally, the observed mass loss rate of Betelgeuse exceeds that of many other stars, reflecting a complex interplay of internal forces. Despite this, with constant energy dissipating, through shock, heating, and mass ejection, Betelgeuse's rhythm is changing. The very nature of these mass losses points to the star's dynamic and somewhat erratic life cycle, prompting astronomers to reconsider their models. The profound aspect of stellar evolution, Betelgeuse's behavior, continues to spark widespread debate among astronomers, who are now rethinking their comprehension of the last steps of a star's life cycle. Whereas stars like our Sun will end their lives in a relatively calm demeanor, changing into white dwarfs, Betelgeuse's enormous size and unique characteristics suggest it may follow a much more violent path. As a supergiant, it has already surpassed the size and mass required to evolve into a white dwarf. Instead, Betelgeuse's inevitable fate seems to lie in a spectacular supernova explosion, a catastrophic event that will leave a neutron star-like remnant core or black hole. The scale of Betelgeuse's mass loss could signal that this transformation may occur sooner than anticipated. Red supergiants like Betelgeuse typically shed substantial amounts in the years preceding their supernova. However, the most recent event, known as the Great Dimming, suggests that this shedding process might be more unpredictable and tumultuous than astronomers had previously thought. This unpredictability has led to a heightened sense of urgency in the study of Betelgeuse as one of the last remaining red supergiants that will eventually undergo such a traumatic event. In the future, astronomers will continue to keep a close eye on Betelgeuse, especially in light of its massive loss rate, which exceeds that of many other stars currently being observed. These observations are crucial in understanding how mass loss contributes to the final stages of the star, and may even provide fresh perspectives on the mechanisms behind the explosion of supernova themselves. The manner in which this process is happening relatively nearby, only 725 light-years away, provides scientists with an unprecedented opportunity to witness a stellar death firsthand, if and when Betelgeuse finally bursts, it could become visible in enough light during the day, it's providing an uncommon and extraordinary spectacle for both professionals and the public alike. While scientists are still unsure of the precise timing, this event could potentially change our understanding of stellar evolution and the fate of massive stars. As technology advances, our available tools to study stars like Betelgeuse will only improve, allowing us to unlock even more of the mysteries of the universe. With every new discovery, the celestial realm becomes even more intriguing. Betelgeuse's drama and progress serves as a reminder of how little we fully comprehend about the final stages of massive stars. While its eventual supernova may be years or even centuries away, every new observation provides invaluable clues about what happens in the death throes of these cosmic giants. As scientists continue to study the intricate behaviors of stars, Betelgeuse, they are forced to reconsider established theories about stellar evolution. The star's erratic dimming, sudden mass ejection, and unusual surface cooling affect all processes that are much more intricate than previously imagined. The peculiarities of Betelgeuse's actions may also lead to revolutionary discoveries in other areas of astrophysics, including convection in the atmospheres of stars and the ways in which stars and their immediate surroundings interact. By analyzing the massive amounts of data collected by instruments like the Hubble Space Telescope, astronomers hope to develop new models that can more accurately predict how other red supergiants will evolve and what signs to look for that a supernova is coming. While the cosmic event that Betelgeuse is heading toward is undoubtedly dramatic, it is just one component of the greater problem of comprehending the life cycle of the universe. The next several years of study could provide answers that revolutionize our comprehension of stars, their ultimate fate, and their role in shaping the cosmos.